at both electrodes. Under this, we can talk about electrolysis of concentrated copper 2 chloride solution. So the setup of that experiment is also as this. So we can simply label our setup apparatus. We have concentrated copper 2 chloride solution. Then we have the battery. We have anode connected to the positive terminal, and we have the cathode connected to the negative terminal. So these are graphite electrodes. As simple as that. So what you have to consider here is that now the solution is concentrated. Ions present. Ions present. We have copper 2 chloride aqueous that is ionizing to give us copper 2 ions aqueous, and the chloride ions aqueous, 2 of them. Then water aqueous, also ionizing to give us hydrogen ions and the hydroxyl ions. What we have to consider here, there are some factors to consider. That the concentration of copper 2 ions is greater than the concentration of the hydrogen ions. Then number 2, the concentration of the chloride ions is also greater than the concentration. I need this bracket to show concentration. So the concentration of the chloride ions is also greater than the concentration of the hydroxyl ions. Why? It's because we have copper 2 chloride as a concentrated solution. So we have more chloride ions than the hydroxyl ions. Then we have more copper 2 ions than the hydrogen ions. So we have to put this into consideration. To the cathode, this side we have copper 2 plus, have copper 2 plus, we have hydrogen, have copper 2 plus, we have hydrogen, have copper 2 plus. So this time around we have more copper ions than hydrogen ions, and we're having 2 cations in this solution. So both copper 2 ions and the hydrogen ions migrate to the cathode, but because copper 2 ions are more concentrated, or are much more than the hydrogen ions in solution, the copper 2 ions are discharged in preference to the hydrogen ions. So what we have at the cathode, we have copper 2 ions being discharged by gaining electrons, forming copper solid balance by putting there a 2. So at the end of it all, we shall have a brown solid formed around this terminal, because it is copper 2 ions that have been discharged, forming a copper solid. So we have a brown coating around there. So at the same time, we have reaction at the anode. Reaction at the anode. So in solution, we have chloride ions, hydroxyl ions, chloride ions, chloride ions, chloride ions. We have more of chloride ions and less of hydroxide ions. We know that from our reactivity series, hydroxyl ions are below chloride ions, and in our first or previous experiment we have been discharging hydroxyl ions in preference to the chloride ions, but in this experiment we are going to discharge chloride ions. Why? Because the concentration of chloride ions in solution is much more than that of the hydroxide ions. So at the end of the experiment, we shall see a brown gas. At the end of the experiment, we are going to see a greenish yellow gas around. So just put bubbles here to represent the greenish yellow gas around the anode. So what happens? You can write the equation for the reaction at the anode. The anode, the chlorine ions, the chloride ions will be discharged by giving away electrons to give us the chlorine gas. But I told you earlier, it's not proper to write a negative in our equation, so I can write the equation properly by saying chloride ions aqueous. Here I have two of them that are being discharged, giving us the chlorine gas, then plus 2 electrons. So this is the proper way of writing the equation. So we are having our equation 1 as this, then equation 2 as that. So we can to the end write the full equation for electrolysis of concentrated copper 2 chloride solution. Full equation is adding equation 1 plus equation 2. So you have copper 2 ions aqueous plus 2 electrons, then plus 2 chloride ions aqueous, then giving us copper solid plus chlorine gas, then plus 2 electrons. What we see is that we have 2 electrons at both sides, so you can easily cancel them out and write properly the equation that will remain with giving us copper 2 ions aqueous plus 2 chloride ions aqueous, then giving us copper solid plus chlorine gas. So we can add this up, giving us copper 2 chloride aqueous, giving us copper solid plus chlorine gas. So we discover that this reaction cannot occur spontaneously. Copper 2 chloride cannot give us copper solid and chlorine gas just like that. We have to induce the reaction by electric current so that it can give us copper solid and the chlorine gas. So we can talk about the applications of electrolysis. We have one, electroplating, where we use a metal to coat another metal, a less reactive metal, to cover another or a more reactive metal. Number 2, we have purification of metals, where we can form a more pure metal free from other impurities. For example, we can purify copper metal to remove the impurities. Number 3, we have extraction of metals, for example, sodium and aluminium. Of course, we use electrolysis. Number 4, we have manufacture of chemicals, for example, sodium hydroxide and chlorine. Those are mainly manufactured by electrolysis. Number 5, we have anodization and dyeing of aluminium, where we have objects made of aluminium coated with a thin layer of aluminium oxide using electricity. Thank you for watching.